Our presentation is on L'Hopital's rule. First piece of advice, learn how to say L'Hopital. Second piece of advice, when you're taking the AP test and you neither know how to spell this thing or what to write to abbreviate it, we'll just let you know that the proper abbreviation is L'H. So what is L'Hopital's rule for? It is basically a shortcut for solving limit statements, which you learned about earlier in the year. However, it can only be used in very specific situations, when the original limit is 0 divided by 0 or infinity divided by infinity. However, there are some cases where you can use algebra to get the original limit into one of these forms and then use L'Hopital's rules. These cases are listed with bullet points that are red. Here is our first example of how to do L'Hopital's rule. So our equation is the limit as x approaches 2 of x minus 2 over x squared minus 4. The first step is to complete the limit as it is right now. So we're going to plug in an x equals 2, which gives us 2 minus 2 over 2 squared minus 4. This obviously equals 0 over 0. This is a perfect case for using L'Hopital's rule. So let's do it. The first thing that we do is take the derivative of the top, which is 1, because the derivative of x is 1 and the derivative of 2 is 0. Then we put that over the derivative of the bottom, which is 2x, because the derivative of x squared is 2x and the derivative of 4 is 0. Then we take the original limit of the new equation. So we're going to again plug in a 2, and this time we get 1/4, because it's 1 over 2 times 2. This is what our original limit statement equals, and your problem is done.
So there may be some cases where you have to L'Hopital more than once, for example, in this problem. So originally, if you plug in a 0 into this problem, you get 0 squared over 1 minus the cosine of 0, which gets you 0 over 0. So this is clearly a form where you have to use L'Hopital's rule. So you take the derivative of the top, which gets you a 2x, and the derivative of the bottom, which gets you a positive sine x. Then you plug in a 0 again to see what the limit will equal. So it's 0 over 0, which means we have to L'Hopital it once more. So if you take the derivative of the top, you get a 2, and if you take the derivative of the bottom, you get a cosine of x. So then you do you plug in a 0 for x, so then you get 2 divided by the cosine of 0, which gets you 2 divided by 1, which gets you 2. So there are some times where L'Hopital's problem can get a little tricky, for example with this one. So for this one, you have the limit as x is approaching 1 for an integral. So if you plug in a 1 for the integral, you get the integral from 1 to 1 of e to the t squared over x squared minus 1. And whenever you have an integral from the same limit, it's always 0. So for this one, we have to think back to the fundamental theorem of calculus to remember what we would do. So the first thing you would do for the fundamental theorem of calculus is, in order to take the derivative, is replace every t with an x. So you get e to the x squared over x squared minus 1. Next, we plug, since the limit is as x is approaching 1, you plug in a 1 for x, which gets you e to the 1 over 1 minus 1. So then you have to do L'Hopital's rule. So you take the derivative of the top, which gets you a 2x e to the x squared over a 2x. And the 2x's can cancel out, and then you're left with the limit as x approaches 1 for e to the x squared, which gets you e. So your final answer is e.
Unfortunately, as math usually does, it gets harder. In this case, you have to use algebra in order to get the proper form to use L'Hopital's rule. First, let's take a look at what we have already. We have the limit as x approaches infinity of x times the sine of 1 over x. So let's do the simple limit statement. We get infinity times sine of 1 over infinity, which equals infinity times 0. Unfortunately, this is not in a traditional form to do L'Hopital's rule, but it is in an alternative one, meaning that we can use algebra to help us get it in the correct form and then do L'Hopital's rule. But first, an algebra lesson, which we all need. For example, if you had 3 divided by 1/2, what would you do? You would take it and multiply it by the reciprocal to get 6. That's an algebra trick that most of us know very well. There's also an algebra trick called reverse flip and multiply. When Hauck first taught our year this trick, we thought that he was crazy, because why would you want to go backwards? But in L'Hopital's rule, it's actually helpful. So thanks, Mr. Hauck. We keep the exact same limit statement. However, instead of multiplying sine of 1 over x times x, we take our sine of 1 over x and divide it by 1 over x. This does not change anything fundamental within the equation. However, when we plug in the infinity now, we get 0 divided by 0, meaning that we can use our friend L'Hopital's rule. So the first thing that we need to do is take the derivative of what we have. The derivative of the top is cosine 1 over x times a negative 1 over x squared. The derivative of the bottom is simply negative 1 over x squared. Yay, they cancel, our favorite move. So now we have the limit as x approaches infinity of the cosine of 1 over x, which equals 1. A nice, neat answer for your limit as x approaches infinity of x times the sine of 1 over x. Now we have some problems for you to try on your own. This is our first. The limit as x approaches 2 of x cubed minus 7x squared plus 10x over x squared plus x minus 6. Obviously, there's a lot of derivatives involved, so have fun. Next, we have something involving a lot of trig. As per usual, the problems that we are giving you are more difficult than the problems that we taught you. However, we think you have the basis of skills to figure these out on your own. But to make life a little bit easier, we did give you the final answers to both problems. So good luck, try it, do your best, and hopefully this will serve you well on the AP test.